A rectangular notch 400 mm long is used for measuring a discharge of 0.003 meter cube per second. An error of 1.5 mm was made while measuring the head over the notch. Calculate the percentage error in the discharge. Assume CD is equal to 0.6. So given a rectangular notch, so generally notches are used to measure discharge or flow rate. So here given rectangular notch, So here given data is given length of rectangular notch 400 mm long means so given length. So length of rectangular notch is 400 mm. Mm means millimeters. Let us convert it into meters. So we know that 1 millimeter is equal to 10 to the power of minus 3 meters. So if you simplify further, you will get 0.400 into 10 to the minus 3. So negative exponent means we have to move 3 places. 1, 2, 3. So 0.4 meters. So length of rectangular notch is 0.4 meters. Next given discharge. So discharge denoted by capital Q is equal to 0.003 meter cube per second. Next given error. So error of 1.5 mm was made while measuring the head over the notch. So error in measurement of head over the notch is 1.5 mm. So error in measurement of head over the notch is denoted by D capital H. So here DH means error in measurement of head over the notch. So 1.5 mm. So 1.5 into mm means 10 to the power of minus 3 meters. 1 mm is equal to 10 to the power of minus 3 meters. So next given CD. CD means coefficient of discharge. CD is equal to 0.6. So finally we have to find percentage error in the discharge. We have to find percentage error in the discharge. So percentage error in the discharge is denoted by dQ by Q. So at last we have to find dQ by Q. So what is the formula for dQ by Q in case of rectangular notch? So in case of rectangular notch, relationship between error in discharge and error in head is given by dQ by Q is equal to 3 by 2 into dH by H into we need percentage. So multiply with 100 into 100. So this is the relationship between percentage of error in discharge and percentage of error in head. Okay, this is the relationship. So here we need dQ by Q. To find dQ by Q, we should know dH and H. Here dH is already given 1.5 mm and only unknown is H. What is H? Here H is head over rectangular notch. Here H for head. So here H means head over rectangular notch. It means height. Simply we can say that height. So we need head. How do we get head? We have a formula for discharge. So in case of rectangular notch, what is the formula for discharge? Discharge Q is equal to, for rectangular notch, discharge over rectangular notch, Q is equal to 2 by 3 into CD into L into root over 2Z into H power 3 by 2. So this is the formula for discharge over rectangular notch. Here our unknown is H. We have to find capital H. Q is already given. Substitute all the values. Here Q is equal to what? Q is equal to 0.003 is equal to 2 by 3 into CD. CD how much? 0.6 into L, length 0.4 meters into root over 2 into 9.81, acceleration due to gravity 9.81 into h power 3 by 2. Let us simplify further. 0.003, 3 ones are and 3 0.2s are. 2 into 0.2, 0.4, 0.4 into 0.4, 0.16. So value of root over 2 into 9.81, its value is approximately 4.43 into h power 3 by 2. Here we need h value. So transpose 0.16 and 4.43 to left hand side. You will get final result h power 3 by 2 is equal to 0.003 whole divided by 0.16 into 4.43. So if you calculate this, you will get h power 3 by 2. Now h power 3 by 2 is equal to 0.003 by 0.16 into 4.43. So its value is 0.7088. So approximately I got 0.7088. So 0.003 by 0.7088, 0.00423. Okay. But here we need h value. So here we have exponent 3 by 2. Apply, to eliminate 3 by 2, apply power 2 by 3 on both sides. Then 3 by 2, 2 by 3 get cancelled. You will get 0.00423 whole power 2 by 3. Now head over rectangular notch is equal to, so final outcome will be 0.02615 meters. So this is head over rectangular notch. So finally we find head over rectangular notch, and then now we have to find dq by q, percentage error in discharge. So dq by q is equal to, this is unknown, 3 by 2 into dh by h. dh is already given 1.5 into 10 to the power of minus 3 by h. Just now we calculated 0.02615 into 100 into 100. So first multiply numerators and denominators separately. Just say 3 into 1.5, 4.5. So 4.5 into 10 to the power of minus 3, you will get 0.0045 into 100 means finally you will get 0.45 by 2 into this. So if you multiply with the 2 table, then this outcome will be 0.0523. 0.0523. Now dq by q is equal to, if you divide 0.45 by 0.0523, you will get the final answer as 8.604%. 8.604%. Therefore, percentage error in discharge over rectangular notches or rectangular wear is 8.604%. This is the final answer.